Ah, welcome to another draft physics presentation. Couldn't sleep, so yeah. But I did think of some things, so maybe I'll bring those up in this conversation about some of these comments. So anyway, William Gelfield, useless drivel as usual. Looks to me like you lost the argument. Whatever the way things look to you doesn't have anything the way they look to me. That's for sure. And I don't think they have anything to do with looking in a sober state at all. So, not very relevant. Alright, so Tyler Johnson, will take him at his word that he's being sincere here. Sorry if I don't fully understand your conception of the way photons behave. I don't know if it was really about photons, it was more about gravity, but anyway, or the overall concept of particles in ether. Well, I'm really not arguing for particles in ether. I'm saying you either replace ether with particles, and it works, or you just understand ether to be made of something granular. So your choice is, it really can't be water. It can't be a medium where the things are bound to each other by, magnetism, by rubber bands, so to speak, the way atoms are. And if you don't have the stuff bound, then it's sort of like grains of sand, as I gave an example. And each grain is going its own way and doing its own thing, and they don't take each other with each other, kind of thing. I tried to make that understood. But anyway, why would the photon duplicate their behavior? So I don't even know what that means. Okay, question mark. As in, why would gravity become magnetism? Okay, well that's a more reasonable question. And it's because of the idea that filtering it changes it. That's all. It's like how to describe a filter. You can have something go through an intersection, or you can have it turn left or turn right. I mean, there's a change that can take place. Now, the fact that the thing went through the intersection is the fact, whether it goes straight or whether it turns right or turns left. So you can sort of get that it still goes through an intersection. But there's a difference if it turns and if it goes straight. And what magnetism is doing is creating a difference by causing it to turn. So it's turning gravity. So it's not only gravity going through the intersection, it's gravity plus turning to produce the ether around the Earth. Why would gravity become magnetism to produce the ether around the Earth? Well, again, it's not magnetism around the Earth. So nowhere did I indicate the Earth was being controlled by magnetism. It's being controlled by gravity. So it's not necessarily doing the turning thing in the same way. So to have magnetism, all the red cars have to turn left and all the blue cars have to turn right. Then you have magnetism. If red cars and blue cars can turn either way, then you have just gravity. To use an analogy, that's the best I can do. If the Earth negates magnetism, again, there's no magnetism in the field energy in space. It's not magnetized, it's not polarized, it's not segregated, it's all mixed out there in space. So the Earth can't negate magnetism because there isn't any yet. The Earth can create some magnetism, but it can't negate that magnetism. Then what does magnetism evolve into? So again, it doesn't evolve into anything. These are just forces interacting with matter bits. Force bits, matter bits. Anyway, just giving it a go. I'm new to physics, but willing to learn. Yeah, well, the trick to learning is you're going to have to watch some of my other videos, I guess, because it's, sorry, it's not simple enough for me to just give you a simple answer. But I'll attempt to. But I might as well do this one first because I think it's got some of the same crap in it. Anyway, so Chicken Little said so. You have come far. Congrats. How would your field diagram look like? How would your field diagram look like for your magnet falling and interacting with, say, the Earth's gravitational field without external influence? Yes, it just does complicate things, right? So when a magnet's in gravity, the point is that gravity is being caused by the Earth. That's a difference in pressure in one direction. The point is the gravity is coming from all directions. It's just when there's no heavy thing next to something, then it isn't going to be pulled in that direction because there's not going to be an absence of force, so the force will be balanced. What a magnet can do is create a segregation of the force, that is a separation, so that another magnet can feel that difference because it's sensitive to the difference. But only things that are in an arrangement that can tell the difference between red and black, in the sense that they're oriented in such a way that they're sensitive to it. The electrons are pointing in the right direction, the protons are pointed in the right direction, so that the force can left turn and right turn. Alright, a magnetic flowing, okay, so I mean it's basically not an unreasonable question. Just saying it's all one force, it's all happening at one time. So when a magnet's creating magnetism, I mean I should have a magnet here, I just don't like keeping them around my electronic equipment, but if I had a magnet and it's creating magnetism, it's being affected at the same time by gravity. It's still obeying the material rules, it's just forcing, instead of right or left turns, it's forcing all the black stuff to take right turns and all the red stuff to take left turns. And therefore it's polarizing the force that comes out of it. The force that goes through and comes out. Gravity doesn't, the only part of gravity that stays in you, quote unquote, is the part that moves you. Alright. If you're not moving, then the gravity's bouncing off of you, essentially. Or it's going through you as another force, in the sense that you're going to create pressure on the thing next to you, which I'll also attempt to explain. Alright, alright, magnet falling interact with, say, the Earth's gravitational field without external influence, such as a metal pipe or a large electronic field. Yes, well, in the regular circumstance, it just acts like regular matter. It's still a magnet. It's still creating polarized force coming out of it, but that can't interact with gravity in any way, so until another magnet shows up, its magnetism is irrelevant to its gravity. And is it not, and is its non-effect a proof of non-interaction of its present force with other forces? Well, again, yes, of course, forces don't interact with forces, so there's never there should never be an argument about that, because it just doesn't happen. And I'll get to one of the gravitational, the one case where photons are supposed to be bent by gravity, and a fact that I realized that's worth pointing out about how they're not using the inverse square law and pretending that the gravity only weakens by the R rule, when it actually is the inverse square law, and they're just pretending because they broke reality. Is it the matter that produces all forces? Is it the matter that produces all forces which have no... See, this is where it just goes totally south. Is it the matter that produces all forces? No. Which have no applicable effect, no appreciable effect on the others until another interaction with matter. Now, there's force bits and there's matter bits. No need to confuse it. I would argue the matter bits are made of force bits, but they're not active. They're locked. So you don't have to think about them. They don't do anything except interpret force. So force hits it, the matter bit interprets the force and sends it in a direction. That's all that really happens here. Of course the matter bit moves, but that's... Does the red destroy? I mean, I don't even know where you get this from. Where could you even come up with any kind of notion of any destruction of matter? It's hard enough to... you can break compounds, that is, you can separate atoms from atoms, but you can't, it's really even hard just to break an atom. It's really, you know, it's not that easy to break a water molecule into hydrogen and oxygen. And it's even harder to break an oxygen elemental atom or a hydrogen atom into its subatomic particles. You know, you can create an ion, but it's really hard to destroy the atom itself. And to destroy electrons and protons is pretty unrealistic. And the does the red destroy and the black create? No, nothing even like that. Does the universe destroy? I can destroy matter to create energy to create matter? No. I mean, obviously in the suns it's doing some of this stuff. So yes, you want to say the universe, sure. But I'm just saying for most of the practical physics you see, you're not going to see any of that happening. This conversion or creation of matter. You know, you just know it's there in the sense that you know that theoretically when you break an atom apart, you release a whole bunch of force. And the force was what was holding it together and was keeping it from being crushed. I mean, that's the other part of what the force is doing. And that gets to the whole pressure argument, which gets to the point that, you know, even though there's no gravity in the center of the Earth, there's a ton of pressure in terms of atomic chemical pressure. So there's still a ton of force being pushed into the center of the Earth. So unless you do create some hollowed out thing, and it would be under, like say if you tried to create a little globe inside the center of the Earth, the roof of that globe would be under extreme intense pressure. So you can't have the freedom, you know, a free environment for cheap, because the gravitational pressure on the surface of the Earth is actually pushing the matter, and it's creating pressure in the center of the Earth. So the force is still being felt. Alright, that might be enough, and I'll go to the videotape, so to speak, the drawings. So this Paul Worth guy is kind of hilarious. He just says the same thing over and over. There is no photons. It's illumination. Now, what do you think illumination is, though? It's just reflecting something off of a surface. You know, you can illuminate a fetus inside a mother's womb with sound waves. So this word illumination doesn't mean anything. That's just reflecting something off of something and getting the bounce back and being able to interpret it into an image if you want. But that's all illumination in most cases is. Certainly the sun illuminates. But again, what purpose would this light be if it didn't bounce off something? There's nothing being illuminated. Just like heat doesn't have packets of heat. Of course it does, in the sense that it produces infrared radiation, which is these photons. These photons hit all the stuff in the atmosphere, and they come to, and some of them get to our eye without hitting anything. So any surface that has heat is likely banging off a bunch of these little infrared photons. So half of what heat is, or some percentage of what heat is the fact that there's a bunch of force being bounced between the electrons on the surface of atoms, and it's jiggling the atoms, and the jiggling of the atoms is essentially a force, because each atom is covered in electrons, and the electrons will bounce off other electrons and give them a nudge. And you know, so, but heat isn't something, heat isn't just one thing. It's not just the movement of a atom, it's the force that's also causing the atoms to move. It's radiation. Well, right there you're not making any sense, because an atom moving isn't exactly something you would call radiation, idiot. Red and black forces, you fool. Whatever that means. You're really dumb. You're old and stupid. And you ought to, you know, do a little better or just fuck off. And this one I'll save for later, because it doesn't say anything but how Ken is wonderful, and the proof is he has subscribers, and therefore that means he's telling the truth and is brilliant. And everybody knows that's how it works in the real world. Is the more views you get on YouTube, obviously the more sense you're talking. It's the way it works, right? Popularity is the definition of correct. I don't think so, retard. I think it probably works exactly the opposite, actually. So anyway, let's do some drawing, and I'll attempt to make it a little clearer if possible. So that's what my effort will be. And I can't say I'll guarantee success, but we'll do the best we can. Alright. So, alright, well I guess I'll do my argument about gravity first, the thing that they miss when they do the Einstein math. So the idea of the inverse square law, okay, is this idea that when you when you expand the space that something is going to occupy, it doubles in both directions. So you have to think when you go twice the distance away. So this is what you get at distance d1. And twice the distance away is d2. And what happens at d2 is the distance, the amount that the distance covers is actually in both directions. So it's 4 times as big as it was here in terms of the amount of space that would be included in the. So you just have to understand it as a if you were to draw it in, you know, a vectory thing, you know, that it's, you know, this idea that the, you know, it gets bigger in this expansive way because it's spreading in 2 directions. Alright, so when a gravitational body is next to a gravitational body, so anything and anything, you can kind of get that the size ratio at this location to any rays of stuff that are coming off would be, you know, you could say this occupies 1 degree of space from the center. And the further away you go, okay, you could sort of understand that these lines are diverging. And if the size of this thing doesn't get any bigger, then it's going to be this little tiny thing in that divergence. And now instead of being 1 degree, so this would be 1 degree still, you know, of the total, you know, 180 degrees both ways. But you can sort of see that it's no longer 1 degree of space that it can occupy. You know, that its matter is much smaller as you go further away as a percentage of that arc. So even if it is a photon in gravity, and even if it isn't moving up and down, you know, going this way, it's just going into the paper. Okay, sorry. So it's not going this way. It's not going up and down. It's just going into the paper this way around, let's say. You can get the idea that it still doesn't matter. The further away I go, the smaller percentage of that arc, that 1 degree arc, I'm going to be exposed to. And it's going to get smaller and smaller and smaller the further away I go, regardless of the fact that it's not moving in that direction. It doesn't have to move in that direction for the rules of gravity to apply. So it's still going to be the inverse square law, which means the mathematics they're using is fundamentally wrong. So it's all made up, in other words. It's just garbage. Okay, they haven't done the Eddington experiment because it frankly can't be done. At the distances from the sun, they're trying to see these deflections. There can't be any because there isn't enough gravity to move the photons. So when they say they successfully did it, they successfully did bad science because there's no theoretical possibility that it can work. Yeah, they're just breaking the rules. They're pretending the photon has no existence, essentially, except in the direction it's moving. They're just saying it has no height, but somehow it has a width. You know, so somehow it's round this way, you know, but it's not round up and down. You know, it's 0 up and down somehow, and yet it's round this way. You know, some kind of bullshit like that. It has a substance in one direction and has no substance in the other dimensions. So they're changing it from a sphere into some sort of frisbee or something. It can't even be a frisbee, like I said, because even a frisbee at a distance still cuts less and less and less. The further away you take it, the less percentage of this arc it will be part of. It'll get smaller and smaller and smaller as a percentage of the arc. So there's no way they can get away with that crap and still be honest physicists, in my opinion. Alright, so to the gravity argument and a magnet. So I'll try to illustrate this more carefully. Alright, so let's make the gravitational body, and let's understand that it's made out of 2 things, you know, electrons and protons. And and that there's a force that's going to hit those electrons and protons inside of atoms. And the trick is see, I guess I'd like to be able to just draw it as an atom. You don't have to draw a really big picture. Just understand that the atoms, not the protons, but the atoms, so let's just pretend that these are atoms, but they're really protons, are connected to each other. That is, they're held bound. So when you hit one, the force goes right through all of them. So just to understand that it's like kinetic balls and stuff like that, they're connected. So when you hit the electron in one atom, the vibration can be traveled through all the atoms. Alright, and so we have the external force that is composed of a mixture in perfect random configuration of red and black. Alright, and there's just a simple rule. The simple rule is the red force reflects off of red, okay, and the black force reflects off of black. So if there's black trapped, it reflects and reflects, it just keeps going back and forth. That's the idea. So it reflects, it goes in and it reflects off. And with red it goes in and it reflects off. Now if black comes into red, it does this turn thing, and if red comes into black, it does the turn thing. Right? So that's all you really need to know. So when gravity is coming in, it's going to hit, when a black one hits the black electron, the black force hits a black electron, it gets reflected back out. And when the red force hits a proton, it gets reflected out. And when the opposite happens, when a red hits an electron, it comes out perpendicularly. And you can see that if it came out perpendicularly this way or that way or this way, in the other two dimensions somewhere it goes out, it would bang into other electrons and protons, and it could end up going almost any direction. Right? If I had another electron here, that force could go bend here and could bend this way, and it could bend this way and bend that way. The point is in all of those turns, that would end up just being random. So it would come out in any direction eventually. Probabilistically, it has no orientation. So the force that gets bent comes out in almost in any possible direction evenly. So it's essentially random in, random out when it's bent. Okay, when it's and when it's reflected, then this electron ends up moving this way, and that's called an acceleration. So when there's a reflection, there's an acceleration of the electron. When there's a reflection for the proton, there's an acceleration of the proton. And that's the force that moves the object in this direction, is the total amount of reflections that take place. And again, off these surfaces, it doesn't have to hit the proton behind the proton behind the proton. It just has to hit the one that it's exposed to, and the force will be conveyed to all the rest, because they're all held in tension by the bonds of the matter. The matter has all the little bits are kind of tightly, they wiggle and they wobble, but they're tightly held. And if you like have an empty gas, that's why gases don't have much, aren't going to be affected much by gravity, is because they, there's nothing holding the atoms together. So each individual electron and proton has to be hit. But anyway, it doesn't really matter. The point is nothing is hidden from the force, essentially, effectively. Alright, and so the point being that if this force doesn't exactly equal this force coming this way, alright, then the object will move wherever the imbalance is. So if there's a little bit more force comes this way, it'll have more reflections. That means it'll cause more motion in this direction. So if this force is equal to that force, then it won't go anywhere. And so the point is when there's an earth in the way, and you're standing on it, or something like that, I can't get this frickin' paper to cooperate. Alright, so, you know, the Earth is doing the same thing this thing is doing, and it's absorbing for its whole diameter here force from the external world. So you can see that as it absorbs force, that it's going to shield this thing from some of this force. It's going to absorb it. It's going to absorb some motion in its direction. And in doing so, it's going to incite this object to move towards it. And as this object moves towards it, it's going to start absorbing more force in this direction. Absorbing is the tricky word. Let me think of a better way to say that. It's going to feel the effect of this being more force because there's going to be less coming from this way. So it's always going to go wherever there's more force. And both objects are doing the same thing to each other. Now the effect of this small object on the big giant Earth will be so small that you won't even be able to detect it. But it's actually doing that. It's when it goes forward, it absorbs energy that doesn't get to the Earth. Obviously, all the reflected energy can't get to the Earth. That's the part to recognize. So anything that reflects back can't get here. I mean, it can't hit it. And therefore, that's the nature of the shadow. Alright, so let me try to do the quick stab at the difference when it's a magnet. So there's no difference. The magnet's doing exactly the same thing that this is doing. And the only difference is that when the magnets are doing the left and right turn thing as they're falling, I guess I can draw it this way. I guess for Earth gravity it'd make it simpler if I did it this way, but it doesn't really matter. And it's falling in gravity. The point would be is obviously any red arrows that hit it are going to just reflect. Any black arrows are just going to reflect any black force, an electron force. And then when the black force goes into the red, the point is that it ends up coming out the black end. So instead of randomly coming out any one of these directions, because of the configuration of the atoms in the magnetic material, the red force that goes into the black end comes out the red end. The black force that goes in the red end comes out the black end. So now the magnet, instead of radiating an equal amount of red and black out of its, you know, the byproduct of the stuff that doesn't reflect, all the stuff that doesn't reflect, instead of coming out in a random mixture like it would with a regular piece of matter, it comes out all black and all red. And therefore, if you put something in that gravity field, it's falling. And if you put another magnet there, well, the other magnet will feel that difference. Let's make them opposites so they attract. Probably would have better do the reflection thing so you can understand it better. But obviously, now all the black coming off of this, because it's all black, it all comes out sideways. It all is bent. It doesn't reflect. So there's ends up being no pressure here because nothing reflects. So if this was, you can do it down here. So when they're opposite, I mean when they're the same. So you can sort of understand. Here, there's all red coming out of this one. There's all black coming out of this one. All the black force comes out, goes perpendicularly, can't reflect. None of the red can reflect off the black. So nothing gets trapped in here. There's nothing bouncing back and forth. And the same for over here. But if it's pole on pole, you can see that all black is coming out of this one, all black is coming out of this one, they just keep reflecting back and forth. And so the closer you bring them together, the more reflections you get, the more pressure you get, the more intense the pressure gets because there's more impacts. And again, impacts are That's the expression of force, is hitting something. And you can change how often something gets hit by just merely bringing them closer together. That's how, in electricity, that's how you create voltage, is you bring electrons closer together, and it increases the pressure between them in terms of the number of times the little bits separating them are bouncing back and forth. And then you can create different forms of radiation based on how close you have them. As I pointed out with photon creation, it would be if two electrons are this close together, when you jiggle them, you vibrate them, then the light can escape, and it's going to escape at this tight frequency. Two bits will pop out at this close frequency, and so that would be ultraviolet light. Okay, and when they're further apart, okay, the little bits are bouncing back and forth and back and forth. You jiggle this, you move this out of alignment, so one of these escapes, and it will escape at this much bigger frequency, and so that would be your infrared light. So the electrons, the pressure between the electrons is what creates the wavelength of the light, and that's why it's so difficult to create X-rays, because X-rays require electrons to be extremely close together to create the very tight wavelength. And to get them that close together, you have to apply a lot of force to force those electrons to be that close together. That is, you have to cram a lot of electrons in a space, or you have to cram a lot of force between them. So, yeah, I think that should be helpful. I don't want to be too redundant and yammery, so maybe we'll go back to the last comment and fiddle with that. And call it almost a video. Really, I don't think there was anything else truly relevant. But nothing, there's no force created anywhere. Everything's just a filter. The force is in the universe, and it's all mixed. And matter bits, electrons and protons, filter the force. That is, they reflect it or they divert it. And by doing that in patterns, as I've pointed out before, the whole right turn thing, 4 right turns is a circle, you get it? That's a trap. So that's how energy is trapped inside of an atom. Is all you got to do is have 4 right turns. Now, you don't have to have 4, you could have 10, you could have 15 turns. As long as you have the 4 more going right than going left, you'll end up back where you started. See if there's anything else that I could throw in. Alright, so there's no forces broken. Photons never die. The same ones that make gravity make light. They make magnetism. They make the forces that hold the protons and electrons together. It's all one thing. And the momentum argument, this gravity argument about how fast you go in gravity, again, as I pointed out, electrons probably can't be accelerated by gravity. They can only be accelerated 10 meters per second. They can never go faster than that. Where a material object can absorb more because of the way the arrangement of the matter. So if you arrange the matter in a specific way, where you have a right angle here, between this direction and this direction, you can understand if this was a proton, let's say, and these were the electrons. And the electron force would just keep right turning here, or left turning. And there obviously has to be an external circumstance that decides which way it turns. But the point would be, is by bouncing back and forth here, by getting this right turn, this force would just end up being a force this way. And that's what gives regular matter its capacity to absorb velocity. It's when the force comes in, it gets caught in those traps, and now it just keeps going back and forth, and it keeps hitting these things forward. And that's the nature of velocity in material objects that are capable of gaining velocity, perpetual velocity. But it's a real force inside the object. It actually absorbs energy to have maintained velocity. acceleration, you don't have to absorb anything. So that when the Earth is being accelerated towards the Sun, it's not absorbing energy, it's just reflecting it. But as it's being, accelerated, if it traps the force, then it gains something called velocity, and that velocity can increase its speed, and it just keeps adding to it through the acceleration. So the acceleration just keeps increasing the velocity, because instead of reflecting, the force is actually getting trapped. Matter can do that. Atoms can do that. But subatomic particles, protons and electrons, can't do that. Alright, back to the comments. Oops, wrong way, I guess. That'll do. Alright, so next, whatever name, dot dash. 14,000 subscribers and maybe 5 videos with more than 500 views. So he's critiquing the fact that this channel isn't as popular as Ken's. First off, let's understand, Ken Wheeler didn't get his popularity by doing physics videos, okay? He did camera videos. Alright. The same folks who offer Ken jobs, I don't know what kind of jobs are these that he's offered. So please, I haven't seen the video where he explains all the jobs he's been offered. The only thing I've seen is the gold thing, and I've gotten emails from guys who've solicited my advice on gold, but I didn't charge them for it or anything like that, and I basically explained to them it's a pretty thin margin you're working with here, so I don't think you have much chance of improving it. There's probably other mechanical ways to use the fact that gold is heavier than most of the other crap in the water, so you really should be able to take advantage of that. But anyway, offer Ken jobs have also viewed your videos. So he says the same folks have viewed my videos, except yes, Ken has over 100,000 subscribers and I have 1,400. So how could it be the same folks? I doubt your theory that everybody watching Ken's videos watched mine and said, ooh, those are poopy, I don't want to watch them. I don't think that actually happened. But no job offers for you. Again, job offer, why should I expect job offers? I'm sorry, I don't really understand. There's physics jobs somewhere? I don't understand. Ken got offered a physics job? Alright, if you offered anything of value, you'd have received more attention after almost 10 years on YouTube. So again, it's the same argument. So if you're not, if you can't compete with the kitten videos and the other stuff, right? Whatever is popular on YouTube is popular for good reasons, not bad reasons. So we're just supposed to believe that popularity is credibility. That's the way it works. Doesn't it, so if there's a unpopular physics teacher or something, it means he's a bad teacher somehow or something, right? That's your logic. I think that's just absolutely silly. You spend an hour making a video that less than 200 people will not even finish watching. Well, that's today. In the future it could be a lot more people. Just depends on how things work out. You want to bet on it for, just for fun? I mean, you want to have a little bit of a bet, okay, that some of those videos are going to get a lot more than 200 videos 10 years from now. But we could just make it 2 years from now. Alright. And again, this is all I make it as clean as possible, right? I mean, Ken Wheeler is a screaming coward. Okay? All of his fans are screaming cowards, just like you. So you're saying out of 150, out of 100,000 viewers, you can't muster up one contender to actually face me live in a room. Just one. Just one of you pussies to show up, alright, and demonstrate how you understand what Ken's talking about. Why don't you do it? Nameless troll, gutless wonder. Alright, emotionally healthy people with real things to do with their time don't do things like that. And here you are watching my video. So, loser much. But whatever. This isn't a counter-argument in any form. I just did a video explaining how what Ken is talking doesn't meet the minimum standards, in the sense that there's a ton of evidence for what he's saying not being true, like the non-existence of electrons, or a lot of the other bullshit he spouts. And you're not counter-arguing any of it. You're just making a pronouncement that Ken must be right because we, idiocracy, the majority of idiocracy, thinks he's really fun and cool. That's all you're saying. And again, I stay right in the video. I mean, I love to test these people and see how much they actually do understand. That they don't really need to understand anything. They don't want to understand how it works. They just want to be told that it's metaphysical, and that it's not that horrible atheism and that nasty, closed universe of mechanics. It's not a mechanical universe. They just want to hear that it's not mechanical, because they don't want to know that they're robots, just acting like dumb robots. You're a robot and your programming sucks. That's a fact that you'll never disprove. So anyway, yes, you're a shitty robot. Alright, by the way, a survey showed that more than 50% of flat earthers consider themselves very religious. Yeah, well, that's, I've already pointed out. I didn't need the survey. It was kind of obvious. There seems to be a correlation between being too stupid to figure out that God is made up and being too stupid to figure out how gravity works. How surprising. Yeah, well, frankly, like I said, you could go even further. It's not just 50%. It's, it's like 98% of people on this planet are clueless fucks, and they're all looking for even the ones who are atheists. I'm an atheist. They're still looking for metaphysical, fun answers to reality. They don't want the fucking truth. All horrible douchebags. Alright, let's see. Sad, but at least it's fixable. That was just a quote of something I had said or somebody, whatever. Yeah, let's see where the quote marks end. Yeah. Oh, there they are. So true. That is the greatest problem of all. Nature building these corrupt brains to serve corrupt purposes. Well, that's really not the problem. Nature didn't corrupt the brains in the sense that, yes, it made them flawed. But clearly, we're so capable of just stepping right over nature. I mean, it's just so easy to do by just acknowledging, oh, my native programming sucks, and the only good stuff in me is the logical stuff, the facts and figures and things. So I'll have respect for what the facts and figures say, and I won't have too much respect for my little selfish, I like cute things. I won't pay much attention to that. Very easy to do. And people just don't want to do it because they're such selfish cunts, and that's the real problem. I mean, this is a matter of an aggressive denial, not a passive ignorance. In most cases, in many cases, and it's surely that for the educated elite, who pretend to have no sense of responsibility. Just like the rich. There's just no sense of responsibility to the world they're sucking the blood out of. Sad, but at least it's fixable. One can hope. Alright, so here's Paul again. Same exact, he just does the same post over again. Light doesn't travel. I mean, it's illumination, so the same words, it's illumination again. Which again, just, I don't know how you don't understand what illumination is. It's reflections, not pockets of light. Can't even say this correctly. Photons, just like when you stand near a fire, packets of heat don't hit you. Well, yeah, they do. Both in the form of infrared radiation, the little force bits hit me, and big blobs of atoms bounce into me, and they're covered in force because they're covered in electrons. The electrons of the atoms hit the electrons of my atoms, and those interactions mean there'll be an increase in pressure. And pressure is heat, in essence. Packets of heat don't hit you. It's radiation, fool. Well, it's not, and you're obviously the fool. And so he says here again, you don't study much atomistics, huh? Their theory is wrong of an atom. When Faraday made up the electron to balance his equations, so another kind of bizarre statement. You know, the idea of charge is just so fundamental. I mean, it's in so many of experiments. There's just no point in denying it. And you really have to have two elements to it. I mean, you have to include them both. You know, you have to have the plus and the minus. You have to have two players here for charge to work. And it's just silly to think you don't, in my opinion. That should have given everyone a clue that something was wrong. So again, it should have given them a clue because you make an accusation that nobody else believes in. So nobody else thinks Faraday made up electrons to balance an equation. Faraday deduced their existence because the facts pointed to their existence. You know, and then a ton of experiments since Faraday have only done volumes to increase the validity of the argument that that's what there are, that these electrons are quite critical to the function of the entire electromagnetic spectrum. Alright, what's your stance on FE, free energy, and ether? Well, of course, I've already answered that a million times. Ether is garbage. Now, free energy is just, you know, you can try to explain to people how energy works, but it is this pressure thing, and it really depends on which side of an imbalance you're on. So there's lots of free energy if you're sitting on the surface of the Earth, you know, essentially. The Earth has been compressed, all right? The force hitting it, it's compressing it. It's under pressure. So in a sense, there's lots of energy there waiting to be released. Just like inside of atoms, they're compressed. And there's lots of energy inside that's waiting to be released, the energy that's keeping the roof from falling in on them, so to speak, keeping them from smashing together, keeping the electrons from smashing together, keeping the protons from smashing together. So there's a bunch of energy in there that's, you know, fighting the external pressure, and it's just kind of waiting for the opportunity to say, I'm free, and, you know, cause havoc. So there's lots of free energy in the sense that you can find places where the spring is compressed. And so you can take advantage and go, bang, you know, fly out off from the spring. And so we can do that with giving gravity, because now the Earth has done all this mass thing, and it's creating this gravitational force, so we can take advantage of stuff falling, okay, in gravity. But yeah, that's only we can't do it in any practical way, because we can't tie a fishing line to an asteroid and then, you know, pull it in and out of gravity and take advantage of the force. You know, there's no way to game the force, okay? But clearly, there is a way to break atoms, and there's a way to break, breaking atoms in the sense of the nuclear bomb thing. So that's sort of pretty free energy. But the problem with its freeness is, yeah, it's a free lunch that you really have to spend a lot on, in terms of the tables and the tablecloths and the cup. You know, you have to spend a lot to be able to get that free energy. So I don't know what else to say about it. But there's no, you have to take advantage of something under pressure, and I guess that would be the way to think about it, because then you kind of understand that, oh yeah, that's always going to be dangerous. You know, the chemical energy is sort of free, right? I mean, the oil in the ground, like for every little ounce of oil, just one little ounce, you know, of oil, it's probably 100 years of solar energy is in that one little ounce of oil. You know, 100 years of solar energy hitting a spot on Earth is in that one little ounce of oil, in terms of how much energy it took to make the compounds, the hydrocarbons in the oil. So to force those atoms into those configurations took a ton of solar energy to do, heat. And so it's free in the sense that you're able to release it. But obviously it's not free in the sense that it'll destroy your environment and you die. So the word free is always just a silly word. So anytime somebody puts the word free in something, it's probably a big fat mistake, because there's just no such thing as free. Either in any sense, either free as in not encumbered, are free in that it doesn't cost anything. Just no such thing. But anyway, enough. I'd like to turn into the balance argument, so you can understand that it's just really about the balance of the force. And there's places where there's an imbalance, and like I said, that's like a compressed spring. You're just taking advantage of some place that's already done the work for you, and you can release the work. Okay. Alright, so the other guy, this fine-tuning argument, I might as well read it. I don't think I did, but about the fine-tuning, first of all, I'm not a religious kook. Yes, you are. I think fine-tuning is evidence for the multiverse. No, it isn't. Which is better explanation than God, in my opinion. No, they're both idiotic. Frankly, there's no way to say it's better for you to create a fake God that has no agenda. That's retarded. Fake gods with no agenda is even dumber than stupid gods with agendas. I probably hadn't made myself clear. Well, it doesn't matter. What I'd like you to do is to calculate the percentage of the possible configurations of your constant. So again, this is just nonsense. So I made it as clear as I could state, in the sense that universes only can work if there's mechanical objects that can do things. So if you can't create an energy trap, your universe ain't going to go very far. It ain't going to get very complicated. If you don't create tension between things, where they can bind together and be locked in positions, then your universe isn't going to do much. So if your universe can't create squares and can't create, let's say, spheres, then it's not going to be able to do any complex geometry. So your universe goes nowhere. But it doesn't matter how you configure it. I mean, it doesn't matter what kind of bizarre thing you might make this stuff out of, or how you might, but the idea of a square and a circle is about as simple as you can get, right? So you can't understand that you have to create things that have balance and symmetry, okay? And if you can do that, then you can create arrangements that do funky things, like wheels go round and roll down hills. You can do things if you can create the geometry to do things, but it's all about geometry. The DNA molecule is about geometry. That's why it's shaped so perfectly and all the rest of it's geometry all over the place. So you can only have complexity when you have the elements of geometry. So the point is, if you start with a checkerboard and you have all the same color squares, nothing much going to happen. So then you have to have two color squares. And then you put pieces on. And to have a game, you can't all have the same color piece. So then you have two color pieces. You see, you just build on the mechanism. But once you have that, I'm saying this universe is that simple, and that's all you need. And the rest of it will grow right out of that. It can. But there's no obligation to create consciousness. There's no obligation for it to create automobiles or do any of this other stuff that we've done. Space shuttles. There's no, you can have a zillion gazillion universes and none of them will have a space shuttle in them. It's this assumption that it always evolves into specific locations is idiotic. It doesn't. Unless it was start off exactly the same configuration, of course. I mean, it's all cause and effect. But there's no calculations to be done. This Drake equation bullshit that you can somehow do a calculation to figure out how rare it is for a water droplet to end up with a amino acid DNA molecule in it, okay, that has two membranes and blah blah blah. The odds against that might be a zillion to one, a gazillion to trillion to one. You don't know. You have no way to calculate anything called odds. It's just a ridiculous. All you know is that it's very rare because you can't do it even in a lab. You can't synthesize it, and on planet Earth it only got synthesized once. So clearly it's not common chemistry, it's very rare chemistry, and that's the least you can say. But it could be preposterously rare chemistry. But whatever, dream on, do whatever you're doing, but do it someplace else, please. Because you're really stupid. Let's see. Yeah, exactly. We have no reason to think, so this is somebody having a conversation, to think it could have been different until we have evidence of a universe where it is different. Let's see. Homo sapien. The assumption is the default. If you have no reason to think it could have been different, you don't think that. accident. I don't know why anybody would think the universe had to make a platypus. No, it didn't have to do that. It could have gone a whole different way. No platypus is necessary. Let's see, you can see the math and figure out the universe can be just fine with different constants. Again, the constants have to produce, and what they have to produce is geometry. So again, if it can't make a square square, and if it can't make a sphere round, then it's not going to work, in my opinion. The universe doesn't have to have stars to exist. Find a reason that the constants couldn't have been different. Anyway, I've done enough, I think, to attempt to make it understood that there is no cosmological argument. The universe is not finely tuned. It's tuned to do basic geometry, and that's it. That's not finely tuned. And the basic geometry was built into the basic forces in the very beginning, so it couldn't help but be symmetrical and to create balance in a sense, because it started off that way. But anyway, people are just so fucking pathetically desperate for some sort of special answer to reality. Ugh, I hate it. So anyway, enough. So till the next time, and such, so forth and whatnot. Yeah, I really think that is enough. Have to be. Well, I think I covered what I need to cover. I made some more good points. There.